Alright, this section or this video itself will be dedicated simply to just solving word problems with substitution and elimination, how to do word problems that involve substitution and elimination. Okay, so let's look at this first one, just to kind of get an idea of what's going on. This way of solving problems is actually really helpful and really useful in other kinds of problems, not just word problems. So for example, when you get to like factoring if you're trying to factor a quadratic equation, you have to figure out like two numbers multiplied to be another number and add to be another number on top of that. You got to find which two numbers do that. This is the kind of thinking that'll let you do that using just math. So here's a way to look at it. Here's the first one. It says the sum of two numbers is 15. Their difference is 1. Find the numbers. Now you could just start thinking of numbers and try to add them and see if they add to 15 and then subtract them and see if they subtract to 1. But that could take a long time, and you know that could take a long time, especially if you've been factoring equations. So let's kind of just get the idea of what we're trying to do here. When it says find the numbers, when it says that, that's what it's telling you your variables are. It says there are two numbers, and those are the variables you're solving for. Let's give letters to those numbers. Let's say that they're A and B. So whatever it says to find, those are your variables. Okay, it says the sum of those two numbers is 15. So it's saying A plus B, the sum of those two numbers, is 15. It says their difference, from what that means subtraction. That says their difference, A minus B, equals 1. It says find the numbers. This is a really easy problem to solve using elimination. Let me get you the idea of what's going on here. All the numbers are lined up, all the letters are lined up. Let's see, the A's equal the A's. You might notice the B's do not equal the B's yet. You got a plus B and a minus B. Those don't equal each other. But you do have A's equal A's. You have A's equal A's. And so we can use that to just eliminate, do a quick elimination here. So I'll just subtract, and we get A minus A is 0. Let's see, positive B minus a negative B, that would be 2B. So let's see, a positive B minus a negative B, that's the same thing as saying B plus B, because negative makes a positive. So we get 2B. So 0 plus 2B equals 15 minus 1, which is 14. Okay, so 2B equals 14, and then divide both sides by 2, B equals 7. Great, so B is 7. Now that we have B is 7, we can just plug that into one of the equations and figure out what the other number is. So we'll just, maybe the first equation. So we'll say that A plus 7 equals 15. Subtract 7 from both sides, you get A equals 8. So A equals 8, B equals 7. So the numbers are 8 and 7. So 8 and 7 are our answers for that problem. Okay, let's look at another one. Alright, Leia and Mike are selling fruit for a school fundraiser. Customers can buy small boxes of tangerines and large boxes of tangerines. Leia sold 3 small boxes of tangerines and 12 large boxes of tangerines for a total of $255. Mike sold 7 small boxes of tangerines and 3 large boxes of tangerines for a total of $120. What is the cost each of 1 small box of tangerines and 1 large box of tangerines? Okay, so we need to just to solve a problem like this, let's figure out what they're asking for. It says they're asking for what is the cost of 1 small box of tangerines and 1 large box of tangerines. In other words, it's asking you to find 1 small box and find 1 large box. That's what your variables are. So the cost of 1 small box of tangerines, that's one variable, and the cost of 1 large box of tangerines, that's another variable. So let's just give them letters. Let's say S is just the cost of 1 small box, and L is the cost of 1 large box. Let's just kind of see where that plays out. And I'll use a capital L for large, just because that way it won't get confused with 1. Okay. So let's see if we can find some equations with this. If we can find some equations for S and L, then we can find the actual variables and we'll have what they're looking for. Okay. So it says customers can buy small boxes of tangerines and large boxes of tangerines. Leia sold 3 small boxes of tangerines and 12 large boxes of tangerines for a total of $255 or $255. Okay, so let's see what that's saying then. If you sell 3 small boxes and 12 large boxes, and totally that costs $255, then the cost, if I were to, if you multiply the cost of a tangerine of a small box times 3, and or if you multiply the total cost, let's see, the total cost of small boxes plus the total cost of large should equal the total cost for tangerines. The total cost. That makes sense. Total cost for small plus total cost for large gives you the total cost in general. And let's see. We found out for Leia, this total cost for small would be, she sold 3 small boxes for the price of whatever one small box costs. So we'll say she sold 3 small boxes for the price of S, of whatever one small box costs. She sold 7 large boxes for the price of whatever one large box costs. So if you add those two things together, you should get Leia's cost. The total cost of hers was $255. $255. Okay. How about the next one? It says Mike sold 7 small boxes of tangerines and 3 large boxes of tangerines for a total of $120. Okay, so he's saying, let's see, the total cost for his small boxes would be 7 times the small boxes, and total cost of the large boxes would be 3 times the large boxes. All that together would be $120. Okay, so if we can solve, oh, look at this, we got two equations now. If we can solve this like a system of equations, we should be able to figure out what S and L are. Okay, let's see what we can do here. Let's see, did I write it wrong? Oh, I'm sorry. I'm so sorry. I wrote 7L. I meant to say 12L for Leia. I hope that didn't confuse you too much. There we go. I don't know how they came out there. I must have read the line wrong. Okay, so we've got 7S, 3S, and 7S, and 12L, and 3L. Let's see, if you subtract, let's see, we couldn't, it looks like everything's all lined up pretty well. This elimination worked pretty well here. But the problem is that if I was to multiply, there's no easy way to line up S and the 3 and the 7. The 3 and 7 and S's don't equal each other, the 12 and the 3 and the L's don't equal each other. And so we've got to find we have to multiply both the equations by some number. Or at least one of the equations by some number in order to make it work, in order to make the L's line up or the S's line up. Okay, well, it seems like making the S's line up would be hard because what's the least common multiple of 3 and 7? The ways to make that line, that seems kind of difficult. But I know that if I multiply 12L, if I take 12L, let's see, if I multiply 3L by 4, that'll give me 12L, and that'll make them line up. So that'll be pretty good. But here's the problem. If I multiply 3L by 4, I'm going to multiply everything by 4 in that equation. So I'm going to multiply all the left side by 4, and I'll multiply the right side by 4. And that'll get me this. So I'll rewrite the top, get 3S plus 12L equals $255. And then I'll get, let's see, 4 times 7 is 28S, and 4 times 3 would be 12L. Great, so that lines up pretty well. That equals, let's see, 4 times 120 would be $480. Okay, so now our L's, positive 12L and positive 12L, line up pretty well. So we can go ahead and do that subtraction method. We can do the elimination and subtract. Okay, so, 3 minus 28, that would be, let's see, I got $3 and I have to buy something that's $28. I still owe $25 even after I give $3. So negative 25S. Let's see, 12 minus 12L minus 12L is just 0 plus 0. And then on the right side, let's see, 255 minus 480. Let's see, that would be negative, because the 480 is larger, be negative 125. So negative 125 would be our answer there. Great. And so we gotta multiply. So we got let's see, negative 25s. Let's see, plus 0. The 0 means nothing, so we'll just say negative 25s equals negative $125. Or that's 125? Yeah, no. Sorry, that's not 125. That's 225. 225. There we go. Hope that wasn't too confusing there. Because 225, let's do this. Let's make sure. 255 plus 225 equals, let's see, that'd be 0 is 3, that'd be 8, and 4. Yep, so 480. Great. So now I'm on track. Maybe one day I'll learn how to do basic math. And we got negative 25s equals negative 225. We divide both sides by negative 25, divide by negative 25. Let's see, so these cancel out. So s equals, let's see, negative 225 divided by 25. Let's see. So 25 goes into 100 4 times. Do that you get $200 though. So that's 8 times, and an extra $25. This is 9 times. So s equals $9. A small box of tangerines is $9. Great. So we found out the first part of our answer. S equals $9. The second part of the answer is just figuring how much a large box of tangerines costs. So we can plug that $9 into either one of these equations, either Leia's or Mike's. And we'll plug it into Leia's because why not? We'll say 3 times $9, because that's the price of a small box of tangerines now, plus 12L equals $255. Let's see. Okay, so we need to get L all by itself. We need to solve for L. So we get 3 times 9 is 27 plus 12L, I guess you say $27, equals $255. Okay, subtract 27 from both sides. You get 12L equals, let's make sure I'm doing this right now. I believe that is $218. That's what that should be. Because if you did 255 minus 27, let's see. So you subtract, this is a 4, so it's 15, 8, 228. It's a good thing I checked, because apparently I can't do basic math in my head. That's $228. Wow, that's unfortunate. Oh man, never mind. Okay. And 228 plus 30. No, wait, 230. Yeah, it's because you're adding $27. I was at $12. Okay, 228. So we have a total of 27. Yeah, 27. Yep. So 12L equals $220. Now we just divide both sides by 12. Divide both sides by 12, and we get 12 divide 12 into 228. And I'm not even gonna just try. I'm just gonna make sure to do this right before I don't embarrass myself again. So we'll do 1. That goes in 12, and that gives us 10. So 108, and 108 goes in. I believe it's 9 times. 9 times. Yes. And so that'd be 108, and minus equals 0. So that'd be a total of 19. So L equals $19, and that's the answer to our large box tangerines. So the answer is as follows. The final answer is small equals $9, and large equals $19. That is our answer, and we're good. Good. Okay, last problem. The school that Jennifer goes to is selling tickets to a fall musical. On the first day, here we go. The school that Jennifer goes to is selling tickets to a fall musical. On the first day of ticket sales, the school sold 10 adult tickets and 7 child tickets for a total of $118. The school took in $120 on the second day by selling 12 adult tickets and 3 child tickets. Find the price of an adult ticket and the price of a child ticket. Okay. So let's see. It's asking us to find the price of an adult ticket and the price of a child ticket. So our variables are an adult ticket and a child ticket. I'll use A and C for those. Okay, so we need to figure out equations based on this. And here's where the numbers come in. It says in the first day of ticket sales, the school sold 10 adult tickets. So 10 adult tickets and 7 child tickets. 7 child tickets for a total of $118 equals $118. That makes sense. So the price of 10 adult tickets plus the price of 7 child tickets equals the total price of $118. That's night 1. Okay, night 2, the school took in $120. They took in $120, so $120 by selling 12 adult tickets and 3 child tickets. Okay, and we need to find the price of both. So this one seems like it won't be so easy for us because because there's no easy way we can't multiply either equation just by one number and get numbers and get A's to be equal or C's to be equal. So we could finish this by doing elimination, and we could multiply both equations by number. I mean, we can multiply the top by 3 and the bottom by 7. I could do this times 3, this times 3, and this times 7, and this times 7. That would get the C's to be lined up. And we could go from there. But just for the sake of making sure you have an example of substitution, I'm going to do this one using substitution. Okay, so I'll just take the second equation and solve for a variable. Let's say we solve for, I don't know, C. Let's try solving for C on the second equation. So we get 12A plus 3C equals $120. We want to solve for C. I just arbitrarily chose that C. So let's solve for it. We get, if we subtract 12A from both sides, we get 3C equals 120 minus 12. Ooh, what is happening to my whiteboard? Aw, bummer. I think, technical difficulties. Oh no. Oh no. And we're back. Okay, so we have, let's see, we had 12A plus 3C equals 120. We subtract 12A from both sides. And we've got 3C equals 120 minus 12A. Okay, and we divide both sides by 3. So we get 3 divided by 3. We get C equals, let's see, 120 divided by 3 is 40. And so we got 40 minus 12A divided by 3 would be just 4A. So 4A. So C equals 40 minus 4A. Great. We can plug that into the other equation and solve for A. Okay, let's do that. So C is the same thing as 40 minus 4A. Let's plug that into the first equation. We got 10A plus 7 times, let's see, 40 minus 4A. And that equals $118. Great. All right. And then we just need to solve for A. So we'll simplify a bit. Let's see, we'll simplify the parentheses. So we have 10A plus 7 times 40. 7 times 40 is 280. Minus 4A is 28A equals $118. Let's see, 28A minus 28A, 10A minus 28A would be negative 18A. So you got 280 minus 18A equals $118. Then the dollars, and then we have, let's see, we're going to get A all by itself, so we'll get rid of the stuff that's furthest away first. So subtract 280, subtract 280, subtract 280, and we got negative 18A equals negative 280 plus 118, or 118 minus 280. The way to do this well is we can think of 280 subtract 118, and we'll make it, the answer will be negative, whatever the answer is. So 280 minus 118, that is the same as 162. There we go. Okay. Really, oh man. It's embarrassing. Okay, minus 162. Okay, 18A, negative 18A equals negative 162. We just got to solve for A. So divide both sides by negative 18, divide by negative 18, and let's see, that looks like 9. I think the answer is 9, but let me check to make sure. So negative 18 into negative 162. If I go 9, that'll give me 72. 9 times 1 is 9, plus 7 is 6, so 16 minus 16, so plus 16. That gives you 0. Good, so the answer is 9. A equals $9. Great. So the adult ticket is $9. Let's find the child ticket now. Okay, the child ticket. We'll plug that into any equation we'd like. Let's just plug it into the first equation, because we can. So we'll say, let's say 10 times 9, because that's the price of adult ticket, plus 7, is it 7? It's 7 times, yeah, 7 times the child ticket equals 118. Okay, so let's see, 10 times 9 is 90, plus 7c equals 118. Subtract 90 from both sides. We get 7c equals 128. Not 128, excuse me, just $28, because 28 plus 90 is 118. Then we divide both sides by 7 to solve for c. Divide by 7, divide by 7, and we get c equals 4. So the price of a child ticket is $4. So our final answer is adult is $9, and child is $4. And that is our final answer. Great.